So today I'll be covering a problem for which I don't have like a problem statement as proper like in some website, but it's written here. So the problem says that you have a string of length n. So you have a string of length n and a number k is given to you, right? Now your question is that you need to find maximum length l such that all possible substrings in that particular string which are of length l, that they should have at most k distinct characters, right? So what do I mean by that is, let's just take an example. So if I take the string ABC ABC, right, and I tell you to find the maximum L, and I give you some value of k as 2, let's say, and I tell you to find the maximum L, such that every substring of length L has at most 2 characters. Then let's just check for that. So see, L equal to 1 is fine, because L equal to 1 if I take, then every substring is distinct. Every substring becomes distinct, and so uh, they won't have more than one distinct character. Okay. Now let's see for L equal to 2. For L equal to 2 also it must be okay, because if I take L equal to 2 and my k is 2, right? So even if characters repeat, I'll have two characters. So at most I can have two distinct characters for L equal to 2. So it's still fine. Now let's check for L equal to 3. So for L equal to 3, this is the first substring of length 3, ABC. So it has three distinct characters, and my limit for k is 2. So that means for L equal to 3 is not okay. So basically my L equal to 2 is my answer, right? Okay, so what do you think is the algorithm then? Like what would be the brute force? The brute force would be that you would just take L equal to 1 and you would see if it works or not, and that working will be checked by sliding window. Like you would slide through the whole string and figure out whether there's any substring of that particular length which has more than k distinct characters, right? Because you're allowed to have at most k, right? So not more than k. So once you get more than k, that means it's just not working, right? Okay. So see, then L equal to 1, and then you would go to L equal to 2, then L equal to 3, and so on, right? Okay. So that means it's not working, because what will happen is that you are checking for all the L's, and each check is taking O of n. So then what is my time complexity? It is O of n square, right? Because let's say if my L is limited to like 1 less than equal to L less than equal to n, so then my n is the maximum limit for L, so my complexity becomes O of n square. So that's not happening, right? But what you can sense here is that if you check for L, can you see this, that if my L equal to 1, let's say, passes, right? Like for this test case, I saw that L equal to 3 failed, because I first got a substring of this particular length which had more than k distinct characters. So can you understand this, that then L equal to 4 would also fail, because there exists a substring of length 3 which has more than k distinct characters. Then therefore there definitely exists a substring of length 4 which has k distinct characters, which has more than k distinct characters, right? So therefore, if L equal to 3 fails, what I'm trying to say is that if L equal to 3 fails, then L equal to 4, L equal to 5, 6, and all subsequent values fail, and all subsequent values fail, right? So now can you think of an approach which has a better time complexity? So then it is binary search, right? Because that's just like predicate, like true, false, then like true, 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 and then it's false, and once it becomes false, it's false for the rest of the pieces, right? So then what happens is that each check for each value of L, each check will again take O of L, but this time all those L's could be completed in O of log n. So therefore my DC becomes O of n log n, right? Okay. So that is quite helpful. So basically the idea is going to be binary search. So what will I do then? Uh, I'll just make a function of check that checks for each value of L, and the rest I'll just write inside my main part. Okay, so let's just make a bool check function, right? What will bool check have? Bool check will definitely have my string s, or should I just assign these things here? Okay, let me do that, so that I don't have to take all inputs, right? So some int 10, which is, let's say, the length of the string, some int k as well, which is something I'll take output. So let's just in s, and then n and k as well. Somehow I don't like taking inputs of strings and integers in the same line. That's why I do this. This makes no sense, but it's just something I like to do. Okay, so okay, what input should I have then? I should have some L as input, right? So L is going to be, my check value, right? For whichever L I'm checking. Okay. So what I'll do is I'll just make a frequency map. So I'll just take map char comma int frequency. So this frequency map is just going to store, right? It's okay. Something happened. I'm so sorry. I think I clicked on some ad. Whatever. Sorry. Okay. So this frequency map is going to track the frequency of elements, right? And see how does the sliding window work. So let's say for L equal to 3, I'll store for ABC, right? Because that's the first substring of length 3, and then I'll just take a pointer, or one single pointer, that basically now the window becomes BCA. So what I need to do is I need to remove A and I need to add A, right? I need to add this index and I need to remove this index, right? So that's the idea. So what I'll do is I'll just keep a count of my distinct characters, right? Okay, so let me just start it like this, that for int I equal to 0, I less than L, I plus plus, and see, when is the character distinct? If its frequency of the map is 0, right, then the character is distinct, right? So if my frequency of some character which I'll get from, so my string is s of I, so if this frequency is 0, then that means it's distinct. So I'll just increment my distinct. Okay, so this small loop just takes care of that. And what I do after this distinct is that, see, it doesn't matter whether this is, so I just increment it, right? So this loop takes care of my first L elements. And see, now in the first substring only, if I'm observing that my distinct has reached a value that's more than k, so I'll simply return false. But let's say that's not the case, so then I'll proceed, and this time I'll proceed from I equal to L, I less than equal to N, I plus plus. Okay. Now tell me what am I trying now? What am I trying? So I'll simply remove my frequency of the character that I had before this, right? So that is actually I minus L. Have I used capital L everywhere? I just love using small L. It's capital L, just do it again because I need to press caps lock every time. That's why. Okay. So this thing I have to decrement. I also have to increment my value of okay. But one important thing, I am also working with this distinct this counter called distinct, right? So if the frequency of whichever element I had, now after removing, if that frequency is now 0, right? If the frequency is now 0, what does that mean? That means that was a distinct element that contributed to the count of distinct. But as I've removed it, I'll simply decrement my distinct. So this thing happens, right? And the next thing is now I'll look at the element or at the lth index, right? So I'll simply do if frequency of s of I there. So sorry. The frequency of s of I, and this is equal to 0, the one that I have now. Then what I do, I'll simply increment my distinct, and along with incrementing my distinct, I also add it to my frequency map. So frequency of s of I will be increased. Okay. And see, so with this I am able to track all my substrings. And what condition do I need to have here? That if somehow my distinct reaches a value that's greater than k, so I'll return false. Okay. So this check is over and this loop is over. Now let's say I've looped through all substrings, right? And still I have not got any false. That means I'm able to do it. So I'll just return true. So this was the check function. I know it looks quite large, but that's fine. Okay. So now come to the int main part. So I've taken input of string, I've taken input of n, k, and all of that. Okay, now tell me what is going to be my left and right. Like what are the minimum values of left and right? So my minimum value of left is nothing but uh, 1, right? Because my k is not less than 1, right? So my limit of k is 1 to n, so my limit of left is also going to be the same, right? So my right is, let's say, my right is going to be the length of the string, so it's n itself, right? And let me just assign some answer as 0. Okay. So now I'll just simply write some binary search code that y left is equal to right. Okay, and what do I do? I just take my mid value, that is mid equal to left plus right 1 2, and what do I check? That if, what did I name the function? Was it check or something? Okay, yeah, it was check. So if my check of mid, okay, now tell me one thing, that let's say whatever value of mid I have, if that is satisfying, what does that mean? That I could still increment it, right? So I just store this value of mid, and I can check for higher values as well. And if that's not the case, so I just need to decrement my mid. Okay, so this is done, I guess. What do I see out after this? Just the answer, right? This ended here, right? See out answer ended. So this is going to give me the maximum value of n.